Before we look at measuring angles with a protractor, we need to look at parts of a protractor first. So when we're taking a look at a protractor, the first thing we want to talk about are the lines on the outside and the ones on the inside. So each of these marks, just like a ruler, designates a certain measurement, and we're counting by ones in the unit of degrees because we measure all angles in degrees. So each of those marks right there represents a degree. And again, we're counting by ones for the little marks, fives for the medium, and tens for the large, which are designated with numbers. The next part we want to talk about is the center point, where the vertical 90-degree mark hits the horizontal line here, and that thing is called the center or the origin. The next piece we're going to talk about is the large line, horizontal line at the bottom that goes from 0 to 180. We call this line the baseline or the zero edge. The next thing we need to talk about are the two sets of numbers that are always seen on a protractor. So the first set is the outer set, and that outer set is called the outer scale. And those are really the numbers we're going to be looking at to use for measuring angles, because they do contain the 1 degree and 5 degree marks, whereas the other set of numbers is called the inner scale, and because those only count by tens and don't have the degree marks, it's a little bit harder to estimate those numbers. Okay, so now we're going to look at measuring angles notes. So if you have the measuring angles notes paper, please go ahead and take that out. It's on the back of the angles vocabulary review. If you don't have that paper, please make sure that you pick it up before continuing with this video. When we're measuring angles, we need to make sure that the arms of the angle, remember the arms are the rays that form the angle. So we have an arm called FE here and an arm called FG here. We have to make sure that they're long enough to be measured on the protractor. And the way we check that is by using the protractor tool. So I'm going to pull that guy out. And we see if the arms are going to extend to the outer degree marks. And it looks like ours are not. So we're going to use the straight edge of our protractor to extend the arms of the angle. So the way that we do that is by taking the edge of the protractor and lining it up against the arms of the angle. Make sure that you're very careful about how you line them up so that it is exactly on top of the arm. And then we'll use our pencil tool to extend that arm line from the vertex all the way out. Make sure you do that for both arms so that you have the arms extended. This will make it easier for us to read the degree measurement on the protractor. It'll give us a more accurate idea of what the measurement of that angle is exactly. Okay. Once you've extended those arms, then we're going to place the center of the protractor. Remember that point is called the center or the origin. It's this point right here where the horizontal and vertical lines meet. We're going to put that on top of the vertex of the angle. Remember, the vertex is the point where the two rays are connected that form the angle. And our vertex here is point F. So we're going to make sure that the center of our protractor is exactly on point F. After we've done that, we're going to make sure the baseline of the protractor is on top of one of the arms of the angle. So right now we have the baseline being on top of this arm, and this arm is pointing to the 180 degrees. I prefer to use the baseline of the arm that's on the left-hand side of the angle, because it makes it easier to go from 0 to 180 instead of having to use some subtraction. So if you'd prefer to do that, all you have to do is rotate your protractor so that the baseline is now on top of the other arm. So that way we're starting at 0 on the outer scale and going to our degree measurement. So now that we've done that, remember we want to make sure that it looks like it is on top of the vertex and one of the arms, not this. This way is not good because it is not on top of the vertex at the center. Once we've done that, we want to measure the degree using the second arm. So this first arm is our baseline. We're going to look at the measurement on the outer scale and see where the second arm is crossing. So for us, it looks like it's crossing at 45 degrees. If you were to say 1 degree more or less, that would be okay, just because the arm is a little bit hard to tell here. Once we do that, we go ahead and write our angle measurement. So this angle, EFG, is 45 degrees. Okay, now before you move on, you want to make sure that your answer makes sense. So when we're looking at our answer from the previous problem, it was an acute angle, and 45 degrees is a measurement of an acute angle, so that makes sense. When we look at the problems down here, the first one doesn't make sense because it's an obtuse angle clearly, and my answer is 47 degrees, which is less than 90, so that would be a measurement of an acute angle, which means my answer isn't possible for this picture. For the second one, this one would also not be possible because the angle drawn is clearly less than 90 degrees, but my answer was more than 90 degrees, so I could not have an obtuse angle measurement for an acute angle that was given to me. For the last one, 50 degrees could be a possible answer because this angle is less than 90 degrees and it looks like it is almost at halfway between 90 degrees and 0, so at 45 or a little bit more. So this is a possible angle measurement for this angle. Okay, the next issue that we have to talk about is measuring reflexive angles. You guys learned about reflexive angles when we did types of angles in day 1. A reflexive angle, remember, measures more than 180 degrees, so it goes more than a straight line. This is example 3 from the You Try practice on that same page. I know this is a reflexive angle because the arc goes on the outer part, which is measuring past 180 degrees. If it wanted this part right here, it would have to put the arc here, and that would be measuring the obtuse angle. So in order to do this, what we're going to do is we're going to again extend the arms if needed. So you'll use your protractor. To save time, I'm going to just use my line tool. But you would use the straight edge of the protractor, put it next to the arm, and extend that arm so that it is easier to read. And again, do the same thing for the other arm as well. From the vertex all the way out. We'll then go ahead and take our protractor tool, and we want the center to be on top of the vertex of the angle. And then we want the baseline to be one of the arms. And again, I usually like to use the baseline that has the 0 outer scale. I want to make sure that the arm is exactly pointing to that 0. And then I use the outer scale to measure. Once I've extended those arms, we're going to measure this first angle. Notice I'm not measuring the reflex angle, I'm measuring the other angle that is in the drawing, because protractors can only measure up to 180 degrees when they are semicircle protractors. So I'm going from 0, and it looks like my second arm is at about 103 degrees. So once I measure that, I'm going to check to make sure that it is logical. Okay, that angle does look like an obtuse angle, so having an angle measurement of 103 degrees is practical for what I just did. Now once I make sure that it makes sense, I'm going to then take that angle measurement and subtract it from 360. The reason why is because the two angles together, if I drew an imaginary arc in the angle that I found the measurement of, that forms a circle, and a circle is made up of 360 degrees. So to find the reflexive angle, I could add the reflexive angle to 103, which would make 360, or do the inverse, take 360 degrees and subtract 103 degrees, and that would give me the measurement of my reflexive angle. So go ahead and take a second. You can either type that in your calculator or do the math off to the side. You should have found that the reflexive angle was 257 degrees. And again, if you're off by 1 degree in either direction or a couple degrees in either direction, that will be okay. We'll just have to get a little bit more practice in being exact. However, if you're off by more than 3 degrees in either direction, that means we've messed up on reading the scale and we need to go back and try again. Okay guys, so go ahead and move on to the next track. If you have any questions, please feel free to ask any of the teachers, and we will make sure that we practice using a protractor before your assessment.